The tool is an Excel-based file as a template and will need to be saved to your local desktop. When opening the tool, the user, if prompted, will need to enable content. If macros is not enabled by the user when opening the sheet, an error message will appear saying cannot run the macro. The user will also have to click yes when the security warning pops up to ask if this file is a trusted document. As the user opens the tool, you will see several tabs along the bottom. The main input tab is titled CTD Input. The main output tab is called Schedule. There are also tabs for Production Rate and Risk and Similar Case Study. We will start by looking at the main input tab, CTD Input. Looking at this tab, you can see a host of inputs. Do not be overwhelmed at this wide expanse of cells. It can be populated only to the degree the user can manage with known information. First, let's go over what the color shading in the cells mean. Light blue fields are required fields. When information is not entered in these boxes, the program will assume default information, which may give conservative or unconservative production rates in the output. The next cell color coding is white or no color. These white cells are information the bridge office hopes to collect when entering new bridges. Such information is not influential in the output, but could give greater functionality to the tool in the future. Shaded gray cells are not used at all. No information is collected or required in these cells. There is hover over text to help guide the user for inputs and insight into data entry. A lot of these text tips are from the standard MnDOT specifications for construction and other MnDOT manuals. There are 3 columns of input, columns F, G, and H. Column F contains quantity-related inputs. If the user does not know the bridge quantity, then they can leave it blank and the program will use default rates. The default rates are located in column P of the same tab and may be reviewed. Column G contains additional inputs related to the type of construction. Drop-down menus are used in column G to make sure the type selection matches the types available in the bridge database. Column H is to be used when trying to get a bridge already constructed into the database to improve the accuracy of the program. The bridge office may be selecting some bridge-controlled projects for inclusion and tracking in the future. Entering a bridge for database inclusion will be covered in a separate video, video number 3. Starting out in the first input section, you can see general project information. Originally, this program was envisioned to generate bridge schedules that would give more conservative schedules with lesser information. The basic premise being that more risk in schedule must be recognized with more unknowns. As of publishing, the tool does not increase schedule based on unknowns. The tool just narrows a field of similar bridges and gives a recommended production rate based on the narrowed database. The second input section in the CTD input sheet, you can see bridge substructure components. This section is broken into subsections to account for each abutment individually along the bridge pier components. There are also up to 4 piers that can be defined, with each being unique from one another. If the user is trying to estimate bridge contract time for a 3-span bridge, enter as much of the abutment and pier data as possible and leave piers 2 through 4 blank. The third section of the input section of the CTD input sheet, you will see bridge superstructure components. This section includes the controlling components of bridge superstructure construction, and the format is similar to the substructure input section. Quantities in the substructure and superstructure sections are mostly direct inputs from the construction plans and are measured in whole numbers. The fourth and final section of the input section in the CTD input sheet is for additional project information for post-construction data collection. This section contains information that the bridge office would like to track over time and at a later date look into incorporating this data into the bridge contract time estimating tool. This section will be covered in video number 3, entering a bridge into the database. So let's review what the CTD input sheet contains. It has a general section for project details, a substructure section for abutments and piers, It also has a superstructure section and additional project data section. As mentioned earlier, the additional project section is not necessary to complete to generate a schedule. It is more for creating a new data addition to the database, which will be covered in video 3. The bridge tool is programmed to produce estimates for maximum 5-span bridges. The tool's intended use is to estimate bridge construction time for standard highway overpass bridges and interchanges. If the user is trying to estimate bridge contract time for large complex bridge projects, it is recommended that the user consider developing a critical path method schedule. Once the user inputs are complete, scroll up to the top of the CTD input sheet to find the Submit Inputs button. This will start a macro that compares with input data with each bridge in the database and creates a list of comparable bridges for each section. Comparable bridges are filtered based on all of the inputs. Before pressing the macro, make sure to save your file. This is because the macro will take anywhere from 5 minutes to 20 minutes to run. It will also slow your computer responsiveness for other tasks. In this video, we will speed ahead and not show the macro completing. The macro completion will create the schedule. Let's switch now to the Schedule tab. Once the CTD input sheet is complete and the Submit Inputs button is clicked, a macro processes the data and populates an estimated construction schedule on the Schedule tab. This tab will give a predicted construction duration in calendar days and working days, as well as a predicted start and finish dates. With the exception of winter work schedule assumptions, the bridge tool does not account for non-working days due to weather impacts. Winter work is defined within the program schedules as between November 15th and April 15th of each calendar year. During the winter work, every other day is treated as contingent non-working days. The definition of winter for this reduced production rate is located in the Settings worksheet. The Settings worksheet is hidden from view, and the user would have to unhide it in order to view the calendar. The current version of the tool does not allow for the user to create a custom calendar to depict exclusion dates or special holidays. This function may be added by the bridge office at a later date, but if there is a need for a special calendar, the user may want to consider developing a critical path method schedule to more accurately depict contract time. The user can choose to display the schedule output in the Summary section at the top of the spreadsheet in the Update Period section. The user can choose from daily, weekly, or monthly. Column G produces an estimated working day duration for the bridge construction activities. Production rates that derive this duration is driven by similar case studies in the database. Here you can see column G. The values listed in column G are all the durations the macro determined from the narrowed set of data based on the CTD input sheet. To the right is column H. Column H shows the activities. Column H shows the logic used to generate the bar chart schedule output. Once a schedule is created, the user may verify that the activities appear appropriate and review the start and stop durations for each activity. Often the user will want to make schedule modifications to better match the bridge. A created schedule may be customized by the user, knowing the specifics of what should be altered. When customizing a schedule, the user should work in a copy of the macro-generated schedule worksheet in order to preserve the formulas. Because of the formulas, you cannot compare the two bridges in the same file. In order to compare or customize bridge schedules, download and save separate copies of the workbook for each bridge from the MnDOT website. The baseline logic in the schedule is based on a standard highway bridge utilizing one crew with some concurrent work. The schedule logic can be modified by revising the predecessor activity ID in column H, predecessor task ID, to show concurrent work with multiple crews. These revisions and assumptions should be reviewed for constructability and from a cost component. Let me demonstrate what I mean. Say you believe the contractor would do near concurrent work on abutment substructures. In this case, the excavation crew would finish at abutment 1 and immediately move to abutment 2. To implement this, I will change the column H predecessor in the excavation activity to be the excavation activity for abutment 1. A more common instance of concurrent work might be in pier construction, where a bridge contains multiple piers and the pile crew moves from pier to pier immediately after completing the pile driving. It is important to discuss the limitations and sources of inaccuracy of the program. The definition of a confidence interval is an estimated range of values determined from a given set of sample data, which is likely to include an unknown population parameter. In order for the bridge tool to estimate a production rate for the range of values, 27 similar case studies are required with the exact same filter applied. If there is an insufficient number of similar case studies in the database, default production rates will be applied to activities when estimating bridge construction time. Now let's return to the schedule sheet. Look at column C. This is the task ID. The task ID has a duration determined from running the macro to filtering data. If the filtered data is too small, then default production rates are used. Let's turn to the production rate sheet, which shows the durations for each task ID that has been determined from running the macro. In column B on this sheet, you can see the heading of Activity ID. This Activity ID is the same thing as the Task ID on the Schedule tab. The Activity ID in column B and description in column C correlate directly to the bar chart schedule generated by the macro in the spreadsheet. There are currently only 70 case study bridges in the database. The program is programmed to hold up to 1,000 bridges, and when more bridges are added to the database, the production rates will continue to be refined. When we started this training video, recall that we showed a worksheet called Risk and Similar Case Study. This sheet provides a list of other factors, besides production rates, that the Federal Highway Administration advises us to consider when determining the contract time for a bridge. The risks listed on the sheet should be in conjunction with your own personal experience and judgment. This sheet also provides a list of similar bridges to the one that was entered in the CTD input page when the tool macro was executed by the user. This allows the user to see if the generated estimate in the schedule sheet is similar in magnitude as previous projects that have already been completed. If desired, the user can extract similar case studies and review the project data for comparison to their project. Extracting a bridge from the database is covered in a separate video, video number 2. When using the tool to estimate bridge construction time, there may be some instances where there is an error that appears in the tool. Most of the errors in the tool are data type mismatches. This can be caused by extra spaces, misspelled words, or the user entering fractional numbers as durations. Pull-down lists were used in all sections of the CTD input sheet when creating the tool to improve data consistency for the end user and reduce the possibility of errors. If there are data entry errors, or if inadequate comparable bridges are in the database, the developed schedule may not be completed by the program. If this occurs, check all of your inputs on the CTD sheet before troubleshooting further. This concludes video 1 of 3 on use of the bridge construction time tool. There are 2 additional videos in this series. Should you have questions on use of the tool, you may email your representing regional bridge construction engineer. The contact information is on the MnDOT Bridge Construction website. Video 2 covers how to extract a bridge from the existing database that you would like to review. This is useful if you would like to see how well the macro processing of the database will compare to the known schedule based on inputs. In other words, simply pulling a database bridge and running the macro is not guaranteed to produce the identical schedule that is in the database already for that bridge. The schedule generated will be the statistically based assessment of the inputs only. Bridge extraction is also useful for generating a schedule that you might want to as a starting point that is known to be very similar to your bridge. Video 3 covers new database entries. In large part, the bridge office staff intend to manage the database to keep it current for all users. They will be increasing the database as project engineers are able to populate new case bridges. The video will teach how new sample bridges are copied to the database. Thank you for trying out the Bridge Construction Time tool.